when the net force on an object is 0, that means, now when the net force on an object is equal to 0, that means that there is no acceleration on the object. In other words, if it has a velocity, that velocity will remain constant, and if it's at rest, it will remain at rest. Also, if the net force on an object is 0, that doesn't necessarily mean that no forces are acting on the object. It just means that the forces are balanced. So for example, if we have a box sitting on a tabletop, the net force on the box is 0. It remains at rest because the normal force provided by the table and the weight of the box, due to its mass's attraction to the mass of Earth, are balanced. So these two forces are equal and opposite in direction, which results in a net force of 0, even though there are still forces acting on the object. So when the net force on an object is 0, that means that all the forces acting on the object have a collective total of 0. It definitely doesn't mean that there's no gravitational force acting on the object, as we just illustrated here. The force of friction is not necessarily 0 on an object where the net force is 0. For example, I could be pushing a box with 10 newtons along the ground, and the frictional force could be resisting me with an equal 10 newtons, but I could still be moving the box at a constant velocity with 0 net force. Then finally, we're going to look at it is accelerating at a constant rate, and that would imply that the net force is non-zero in order to provide that constant acceleration. So we can clearly see that this is the best choice for this problem.